Welcome to Investigation 3.3 from Say It With Symbols. In this investigation, we're going to be factoring quadratic equations. So, we've done a little bit of this already before. We did this with frogs, fleas, and painted cubes, but we'll get some more practice, which is always a good thing, especially when it comes to quadratics. So, a word worth knowing that we need to add is roots. And in frogs, fleas, and painted cubes, we had a definition for roots, and it was actually called something slightly different. It was called solutions. So a solution to a quadratic equation can also be called a root. So a solution to a quadratic equation is typically where our parabola, whether it's pointed up or down, crosses the x-axis. Those are our roots, and we can either have 0 of them, 1 of them, or 2 of them. There can be up to 0, 1, or 2 solutions, or 0, 1, or 2 roots. So those are essentially just where it crosses the x-axis. We need to find out how to solve for these, and so that's exactly what we're going to be doing with this investigation. So we have a little bit of information here. This is from your book. If you look at your book, you'll see this exact table and graph. Here is a particular graph and table for this function. Y is equal to x squared plus 5x. And looking at this, we can see that we have a root at 0, 0, and there's another root at negative 5, 0. This is also seen with our equation, or with our table, where we see a 0 opposite a number. So we'll see a 0 in the y area because these roots, they don't go vertically in the y-axis. So what is the factored form of this particular equation? We've been looking at this sort of thing. We can essentially look at this and say, well, this is a rectangular model that is x squared and 5x. So that tells me that my side length for one of my sides is x and my other side length is x plus 5. So we can rewrite this as saying x squared plus 5x is equal to the factored form x times x plus 5. Essentially, we can undistribute an x from each of these two terms, x squared and 5x. What is the relationship between the factored form and the y-intercepts of the graph? If I look at my factored form, we have x times x plus 5 as our factored form, and if I look at my various y-intercepts, I have negative 5, 0. That looks like it's related there somehow. And we also have 0, 0, which looks like it could potentially be related here somewhere. So perhaps there's some sort of relationship there. Let's move on a little bit. We have this situation. Here's our rectangle model. It's x squared plus 2x plus 3x plus 6, or we have the complete expanded form of the equation, x squared plus 5x plus 6. To factor the expression above, Trevor, random dude, draws the area model shown to the left. Does this model represent x squared plus 5x plus 6? I sure hope you're screaming, yes, of course it does, because x squared plus 2x plus 3x plus 6 can simplify because we have like terms here. We have 2x and 3x, they can be added together, and we'd end up with 5x. We still have our plus 6, and we still have our x squared. So does the model represent that particular equation? Yes. Awesome. What are the factors of this? So let's look at figuring out the side lengths of this particular area model. If I were to look at the side length for x squared and 2x, we know we have to have an x to multiply both of them. If I look above there, we have 3x and 6. We'd need a 3 to make that happen. Up above, if we were looking vertically, we'd have x squared and 3x. We again need an x. And 6 and 2x, we need a 2 in there. So our factored form of this particular equation is x plus 3 times x plus 2. What are the x-intercepts of this particular graph? Let's find out exactly what they are. Let's draw this graph. Okay, so magically, I'm starting to draw a graph here. I have the x squared plus 5x plus 6. I decided to create myself a table of values. I started my table of values at -4 and I went to +4 for my x. And what I noticed is I would get 2, 0, 0, 2, 6, 12, 20, 30, 42. So I can see that change that was starting to occur was essentially an addition of 2 more added on. So we had the -2, a 0, a 2, a 4, a 6, an 8, and so on. So there was a +2 change, or second difference in these values. Then from there I also noticed that right in between the 3 and the 2, or -3 and -2, that must be where my vertex is, because everything is going up from there and in both directions. So that's kind of where everything is headed. So if I did my line of symmetry equation, -b over 2a, I come up with -2 divided by 2 times 1, or -5 divided by 2 times 1, and I end up getting -2.5. And then putting that into the equation, I found the y that goes along with that. So I was then able to plot these points, and if I now connect the dots, we can see the parabola form. So there's our dots. We can see also that we have our x-intercepts at -3, 0, and -2, 0. So those are our solutions to that equation. Now let's go over to our actual problem here. It says, what are the x-intercepts of the graph? And our x-intercepts, we just said, were -3, 0, and -2, 0. And if I look at this, what is the relationship between the x-intercepts and the factored form of the expression? Let's look at that. My x-intercepts are the opposite values of the factored form. So if I look at that, -3 is exactly the opposite of a +3. -2 is exactly the opposite of +2. So that's an interesting relationship. Let's use that method, or let's factor these two equations. That's the next part of this. What method can be used for the quadratic equation like the ones below? We have 4x squared plus 32x, and then 4x squared plus 4x plus 1. We need to factor these babies. If we had x squared plus 5x plus 6, we can either go the route of making that rectangle and finding the side lengths and figuring out the factored form. We could also go the route of saying, okay, what are the numbers that multiply to get 6? 1 and 6. 2 and 3, and we could also look at negative values of those, -1 and -6, and -2 and -3, and then looking at that, which ones of these add up to get me 5? Well, this one adds to 7, this is 5, this is -7, and -5, so technically these are my values that would work, so I would say x plus 2 times x plus 3. And that's nice and exciting. But we also need to be able to factor other forms of a quadratic equation. So let's do just that. We have that 4x plus 30, or 4x squared plus 32x. One thing that I notice with this, the only way that I feel like I can factor it is just looking for a greatest common factor between my two terms. If I look at 4x squared, I could say this is 1 times 4, And then I also have this x times x in there. If I look at my 32x, I can say that is 8 times 4, and there's also an x in there. Because I can find all these different things and some things that are in common, that means I can undistribute some of them. I notice I have a 4 in both, and I notice I have an x in both. So that means I can take this information out and bring it out in front. So I could say 4x, bring that baby out in front, and the stuff that's remaining is 1x plus 8. And that's what's remaining. If I wanted to, I could redistribute it to make sure it still makes sense. 4x times 1x equals 4x squared, and 4x times 8 would get me 32x. As well, I can do the same, or I can do something interesting over here. I have 4x squared plus 4x plus 1. I need to factor this baby as well. And I'm going to use a similar method as to looking at some of the factors on these end parts. If I look at 4x squared, I can say this is 2 times 2, or I could also say it's 1 times 4. And on this end with the 1, it's essentially 1 times 1. That's the only thing we can do. Now there's still an x squared there, so I know that I'm going to have an x at the front of each of my equations, and I'm actually going to give myself a little bit more room because it looks like I'm going to be writing a number in front of them. X, and there's also going to be a plus, and my very last thing is going to be a 1. So somehow I need to do a little bit of math to make this front number instead of the back number add to be 4. What number is going to do that? Well, 2 and 2 would do that. 1 and 4, that adds to be 5 if I were to add those together. 2 and 2, however, 4 all the way. So I'm going to say 2x and 2x. 2x plus 1 times 2x plus 1, or 2x plus 1 squared. These are solutions. These are the factored forms of our previous quadratic equations. From here, if we wanted to, we can even use these solutions to be able to solve for x. What would x be if y was equal to 0? So 4x times 1x plus 8. We could play around and figure out what would x need to be here to create a 0. Well, x would need to be equal to 0 to make that happen. And what would x need to be here to make this equal to 0? And that might take a little bit more work, but I'd guess that you'd eventually get -1/8. Play around with this concept of factoring quadratic equations and finding roots of them, and enjoy this investigation. Work yourself through it, and if you finish early, try investigation 3.4. Thanks so much for watching, and I'll see you later.